conscious or tatanong niya. See. Eh, mga detalye yan sir eh. Ano mo na yun?
Pwede na lang.
Oh.
Good afternoon po. What are your views about the construction of slabs and columns, and how are they made?
Construction of slabs, no, if it is concrete. So concrete is very commonly used as our structural flooring in the Philippines and basically also all over the world. Now, if it is for like conventional, continuous lang yan eh. So, yung slab yun na there's a thickness na minimum 100, and it varies, depends on how
100 in 4 inches in English.
4 inches in English, 100 milliliters in metric, yun ang minimum, and then it varies depende din sa span. Now, it is composed of concrete na may cement, gravel, and sand. Tapos, meron siyang reinforcement. Reinforcement would be depending on the position of the slab. Nasa center, kapag kung nandun sa gitna yung ano. Do you already have subject na design?
RC
Design.
Steel and RCD po.
So you are already familiar on how the placing of the reinforcement would be. Tama. So, yun. Conventionally, it's widely used. Tapos meron ding we have other system din. Pero if we are into technical na aspect, reinforced concrete is still ideal in the Philippines. Although may mga ibang systems na rin.
Okay.
Ano po yung ibang systems na pwedeng, yung kagaya po, di ba ideal po dito yung reinforced concrete? Ano
If
po
you
yung
are
iba?
familiar, it is also reinforced concrete pero deck siya. Are you familiar with steel decking? So it's corrugated. Para siyang, imagine yung mga roofing. May corrugation siyang ganun.
Okay.
So instead of formworks, yun ang ilalagay, bubuhusan, and then they don't have to remove the decking anymore. And then added reinforcement na rin siya. And then we also have slabs na manipis lang, but meron siyang plate, like what we're doing dun sa mga di ba? Sa mga warehouse din, na gusto nilang magaan lang.
Grids, mga grids.
Yes.
May
Tapos
reinforcement pa po yun.
meron siyang mesh lang.
Oo, mas meron siyang WWF. Welded wire fabric.
Yeah. Pero depende sa costing yun eh, kasi binabalance yun ng project. Saka yung availability of the plate na ilalagay. So instead of corrugated, it is flat. Yun naman.
Next question.
Next question po. Are you using singly reinforced design in your computations? Is it true that the design of singly reinforced bar are not followed during construction, but instead workers make them doubly reinforced?
Yes, we analyze our reinforced beams and slab as singly reinforced. It is true that we need additional rebars, but it depends on the definition of doubly reinforced, because it's not gonna be doubly reinforced technically, dahil it would only serve as temperature bar for the top portion of the beam. So construction, it's not really true na doubly reinforced. Kasi if you say doubly reinforced, and ibabalance yung marami kang bottom bars, kung nasa gitna ng stress part, and then at the top, almost the same number is for it to up
Okay.
as doubly reinforced. Pero in layman's term, mukha siyang doubly reinforced kasi you have the top bars and then you have the bottom bars. Pero iba yung use ng top bar during construction.
Ano po yung use po niya?
shrinkage, deterioration, minimum labor. Pero it would be, the concrete would be more na, mag-absorb dun sa compression part, di ba?
Opo.
And if you remember your stress diagram ng concrete, nasa top, compression, sa baba, tension.
Tension po.
Now, dun sa top, since konti lang yung rebar, yung concrete lang yung yung nagre-resist
Opo.
on that compression. Hindi pa ma-absorb. Kung konti lang yung rebars.
Reverse.
Okay. One thing here, nakalagay dito, is it true that the design of singly reinforced bar are not followed during construction, but instead, workers make them doubly? Dito kasi sa amin, as practice namin dito, what is shown in the drawing should be the one constructed. Hindi pwede yung
Hindi po yun.
yung nasa drawing, tapos hindi
Iba sa
papasok
construction.
construction. So hindi nangyayari ito dito sa amin. Okay, siguro
Pero technically,
sa local project natin, mo buildings dito sa atin, baka nangyayari. Pero dito sa amin hindi.
Okay.
pero in general, technically kasi,
And it should not be happen. What is in the drawing should be the one
should
we put
be
in construction.
implemented.
Yes. Okay.
Then, next question po. Can you show us detailing and computation, maybe a sample of what you are doing, and a brief discussion of the things to consider in the design of beams and columns with respect to reinforced concrete?
there is a restriction to share our information here in the office, although I can share with you the theoretical approach of the design and what to consider. Now, what you have to consider is the ratio of the depth and if you are talking about beams, you need to consider the depth and the width. Kasi there is an economical way of determining that. If you have a shallow beam, then the reinforcement would not be economical. And then if you have a deeper beam, then the reinforcement will be economical. Kasi based on, you still remember those, syempre, kasi strain diagram. Now, but we also have to consider the headroom. So, the deeper the beam then, that would lessen the headroom clearance. So,
Especially for buildings, normally yung mga architects ang magdidikta ng mga sizes ng mga beams, di ba?
Opo.
Columns, beams. Good if hindi sa mga building like us here, we're doing industrial structures. Hindi masyadong ano yung architectural. Walang architectural pa mga. Hindi nare-restrict
Sa industrial po ang
sa industry.
yun.
Ang
Okay,
nare-restrict
so,
lang sa amin, yung mga headroom clearances, so that, yun napapalo yung mga depths ng beam.
For economy, mas economical pa rin yung deeper beam. Huwag naman yung so much. May ratio rin yun. It can be 1:2. Yung 1 yung width, 2 yung depth. Yung mga tipong ganyan. So, as you progress on your studies, you'll be able to determine the economical way of sizing yung beam. And then you also have to consider the spacing ng beam. Kasi if it is closer, it wouldn't be economical. If it is so much farther, it wouldn't be economical to the slab. Kakapal naman yung slab ninyo.
sakto lang po.
So, meron din kami sinusunod yan. Well, depende din sa, we call it engineering judgment. Meron mga engineers that they don't go further than 3 meters. Or they can go further if the minimum is 150. Basta meron mga ganun rules. So, first, yung sizing. Second, yung spacing. Consider. And then yung column naman, it depends on where the strong axis. Have you analyzed buildings na? Kasi, we haven't. So, there's such thing na a strong axis and weak axis of the building. Pag ganito yung configuration ng building ninyo, where would be the weaker axis? Sige, isipin mo na lang na pinto. Nasa ng weak axis?
Ito po.
Here. So, sa building nyo, ito rin yung weak axis. So, dapat panibayin. The configuration of the column would be, pahaba naman siya ganun. So, now, kung square yan,
Ibig
ibig
sa
sabihin,
column, kung rectangular yung column, dapat rectangular, ano? Tama ba?
kung rectangular yan,
Yung length, yung width.
rectangular siya. Ito yung mahaba, ito yung maliit.
Yung wave po.
Yes. To resist yung swelling. Kasi dito, kung maraming columns dyan,
Matibay
it
na.
will be stronger. So kahit mas maliit yung weight.
Mas rigid po.
Yes. So another consideration is, depende rin sa length ng beam na dinadala niya. If it is square naman, so square, pwedeng pare-pareho lang yung size nun, di ba? But then, paano yung spacing? Pag nandito yung mahaba, wala tayong, ganun po. Kahit sabihin natin, square yan, hindi natin basta-basta ma-judge na it can be uniform na square ang size ng column. What if, ganito yung spacing mo, ganito yung column,